Hello, and welcome to today's webinar on wind and solar data visualization with Python. In particular, we'll be talking about creating interactive wind and solar time series plots with the NRGpy and Bokeh Python libraries today. My name is Natalie Babij, and I'm an analytics engineer at NRG Systems. I've been with NRG for about 7 years, and I've also been working in the renewable energy industry, working with meteorological data in various capacities for close to 15 years. And over the past few years, I've increasingly been using Python as a tool for data analysis and visualization. Now, as you can imagine, data visualization using Python is a huge topic, and the goal of today's webinar is to set you on a track toward generating your own plots from wind or solar data that you've collected from NRG loggers using functions available in NRGpy, pandas, as well as my go-to visualization library, Bokeh. I'll show you some basic examples and provide you resources for further learning and exploration. So let's get started. What I have open here is a Jupyter notebook, and this is where I'll be providing a demonstration for you. I'll mention that it's possible for you to replicate everything that I'm showing you here today, even if you don't have any prior knowledge or experience with Python. However, to fully understand the how and why behind each line of code, it does help to have some Python programming experience. So I'll provide some resources for further learning at the end of the webinar if you want to take this further and deepen your understanding and take these concepts beyond just the examples that I'm providing today. So the first thing that you'll see here in this top cell is the packages that need to be installed to run the code that I'm demonstrating today. So I already have these installed locally, but if you didn't, you would want to uncomment these lines and run the pip command to install NRGpy, pandas, and Bokeh. So the first package is NRGpy, which is NRG's own open source Python library for interacting with data from NRG devices, as well as interfacing with the NRG Cloud APIs. My colleague Dave Carlson gave a great webinar about using NRGpy a couple months ago, which I recommend checking out as an introduction to NRGpy if you're unfamiliar with it. You can find a recording of the webinar on our website. Here's the link right here. If you go to nrgsystems.com and just search for NRGpy webinar, it'll come up. And here's also the GitHub page for NRGpy. Next we have pandas, which is a very widely used Python library for data analysis and manipulation. It's built around the DataFrame object, which is a really convenient way to work with tabular data, and that includes data like the time series data that we're commonly working with for wind and solar projects. And when NRGpy reads in data from NRG devices, it stores it in pandas data frames. So that's why we're using pandas in conjunction with NRGpy. And you actually don't need to install pandas on its own if you install NRGpy, because pandas is a dependency of NRGpy, so the installation of NRGpy will handle that as well. And here's just a link to the pandas page. And then finally, we have Bokeh, which I mentioned is my personal go-to Python library for data visualization. There are a lot of data visualization libraries available in Python. Some other popular ones are matplotlib and plotly. And if you prefer working in any of those, you'll find that they integrate well with NRGpy also. Personally, I like to work with Bokeh because it allows you to make interactive plots that are stored right in HTML files, making them easily shareable while maintaining their interactivity. The plots are also highly customizable in a way that's relatively intuitive once you get a hang of the basic structure of Bokeh objects. I'll be honest, there's a bit of a learning curve there, but it's worth it for how powerful the library is once you do get a handle of it. And here's the Bokeh website with plenty of documentation and examples of some of the visualizations you can do with it. So first thing we'll do here is import these packages into this notebook here. You may or may not want to or need to import pandas explicitly here, depending on how you're handling the data. In the examples I'll be showing today, we'll be using some DataFrame methods that are implicit to the objects created through NRGpy, so we don't actually need to import pandas here, but if you wanted to do some further manipulation, you might be using the pandas library directly. And then for Bokeh, the convention is to import the specific classes and functions you need from its various sub-packages. So here we have the Bokeh IO sub-package, which includes functions for displaying and exporting plots. The model sub-package contains various objects that might be integrated into your figures. Palettes contains color palettes, and plotting includes the core figure generation function. So now we'll want some data to work with for our plots. So we'll download data from a couple sites that I have access to on NRG Cloud. You can do the same thing with any sites that you have access to. If you don't have an NRG Cloud account yet, you can go to cloud.nrgsystems.com, which I have open right here, and you can sign up for a free account right here, and then you can go ahead and upload some data if you have some RLD files available, and then you can do the same thing that I'm doing right here. So in this set of cells here, I'm using NRGpy to make an API call to NRG Cloud to export data from two different sites. So here I'm just grabbing my API credentials from an external file where I have them saved, and here I have the parameters of one of the sites that I'll be downloading data from and the date range that I want to be using. So you can use similar code and just update it to your site. And let me just start getting these going because it might take a minute. Shoot. So I'll go ahead and run this set of cells here. It might take a minute just to download that data from the cloud. And if you want to learn more about this particular set of code, again, I recommend you checking out that NRGpy webinar, which goes into detail about how to use NRGpy to export data from NRG Cloud and use some of NRGpy's other functionality. So these two sites that I'm grabbing data from are one is a test solar station we have on our NRG campus here in Vermont. The other is a test wind tower we had offsite. Both of them used SymphoniePRO Data Loggers. And I'm ending up with, from each of them, an NRGpy reader object with data from these devices. So that's here what we're calling solar site and wind site. We'll often use the convention, we'll just call it a reader, since it's a reader object, but since I'm creating two of these objects at once, I just want to differentiate them as solar site and wind site. And as you can see by the start and end dates that I assigned here, I pulled 1 week of data from each of them. So let's get to plotting some solar data. One thing I can do just to kind of take a quick look at my data is I can run an interval check from NRGpy and just see this is the date range that I have and that the data set is complete over that date range. The NRGpy reader object also has an attribute called channel info, which I'll show you here. So this is a data frame with channel details that are contained in the header section of the SymphoniePRO export files, but just condenses it into this nice tabular format so you can see all the channels that we have active on this logger and what's connected to them and some other details about them. So it's nice to take a quick look at this and just get a sense of the data that we're working with. So in this particular example, I'd like to plot some irradiance data, and so we can take a look at this table and see what we have for sensors that are measuring irradiance. And so I see on channel 14 here, there's an RC18 reference cell, and then going down, we have these channels 27, 28, and 29. We have a couple MS40M pyranometers, one measuring GHI, one plane of array radiance, and then we have another reference cell measuring plane of array. So let's create a time series that looks at these 4 data streams together. So the time series measurement data in the NRGpy reader object is stored in an attribute called data, which is another pandas DataFrame object. And if we want a sense of how that's formatted, we can call the head method, which is, so that's a pandas method that shows the first 5 lines of a data frame. And if you're familiar with SymphoniePRO data exports, you can see that this data frame looks just like the data would in an export text file. You have your timestamp column, and then you have a column for each statistic for each channel. So to simplify things, I'd like to make a trimmed down data frame that contains only the data that I want to plot. So that would be the average data column from the 4 channels with irradiance measurements. So in order to do that, I'll need to reference the specific column names that I want to keep. And there's ways to do that programmatically. You can also kind of just look at all the names of the columns and copy and paste the ones that you're interested in. So I'll just show that approach here. So you can do solarsite.data.columns, and again, columns is a pandas attribute of the data frame, and shows me all my column names. And then from here I can just grab the exact column names that I'm interested in, and I have this list of column names called irrad columns where I've pasted those names in, and then I can create this data frame that I'm calling irrad data, and I'm using the pandas convention for indexing and subsetting data frames to just grab the timestamp column and those 4 irradiance columns. And so if we want to see what that looks like, just run this cell. And there you go. So just 5 columns of the data that we want. All right, so now that we have our data that we want to work with, we can actually move on to plotting. So the first cell that I'm going to run here just has this output notebook function, which I imported from the Bokeh IO subpackage. And this is just saying that since I'm running this in a Jupyter notebook, that when I generate my plots, I want them to be displayed right in the notebook. And here in this cell, we'll kind of start working you through the process of creating a plot. So the first thing you need to do is create a figure, and the convention is to assign that figure to a variable p. And then to show the figure, here's enter show p, clean that up, and there's our figure. And so you can see it's blank. It's giving you this warning that there's no data in there because we haven't put any data in there. But this is the first step to creating that figure object. The next thing we can do is change the dimensions of it. So I will assign it height 400, width 1400, and that's a nice size and dimensions for a week of time series data. The next thing we'll want to do is add some data. So in these plots, the data is plotted based on the x and y coordinates, and the marker for each data point is called a glyph. So here I'd like to create a line plot, so I will add a line glyph by doing p.line, and then I just need to tell it the x and y coordinates where that line will be drawn. So our x will be, we'll pull the data from that IRAD data frame, and that will be the timestamp. And the y, we'll just do the first of the irradiance columns now. So IRAD data. Let's see how that works for us. All right, so we have a time series plot now. This is a little tighter on the screen than I expected, so maybe I'll just trim down that width a little bit. All right, now we can see the whole thing. Great. And one of the first things I want to point out here is that you'll notice this toolbar on the right. Bokeh has several interactive features that are built right into its figures by default. You can change these if you want to, but this is the standard tools that will show up. So this top one is selected. This is a pan tool, so you can just click and drag to different parts of the plot. If you select the next one down, that's a box zoom, so you can click and drag to create a box of any shape or size, and then it'll zoom into that area. You also have a scrolling option, which, all right, I don't actually have a physical mouse here, but this seems to be working, so you can scroll in and out on your mouse to zoom as well. And you also have the option to save this figure to a PNG file right from this interface here. And then lastly down here, this will just reset it to the original view. And then there's a lot of things you can do to customize the look and feel of your figure here. For example, you can change colors, and this color parameter, there's a huge library of color names that you can use. So if you just come up with a color that you want to see, it'll probably exist. So like orange, red, I can do that. Also, I mentioned the concept of glyphs. So if instead of wanting a line, if I wanted it to be like a scatter plot of circles, I could do circle. And then we'll go back to our line. And then say I want, a slightly thicker line. I can change my line width to 2. And so that's just a little flavor of how you can customize the output of your plot. We'll also want to add some annotations here so that we know what we're looking at. So you can add a title right in this figure call here. So we can say title solar site irradiance. And now it adds a title. I'm not crazy about where I put it here, so I can go ahead and update a couple attributes. Do title align equals center, and then I can also change some font properties. What is it here? Sorry. Text font size. It's 12 point. So now that centered it, made it a little bigger. You'll notice the x-axis has some funky numbers on here. This is supposed to be our timestamp on the bottom here. So really what we'd like to see is some dates and times. Fortunately, Bokeh knows how to interpret timestamp data, but we just need to tell it that that's what we're feeding it. So that again is done right in this figure call here, and I can set x-axis type to date time. And now we have the dates here. And you'll see if I zoom in, it'll zoom in to the hours. And I think if I keep zooming in, then it'll do hours and minutes. And if you don't like the way that these are formatted, if you want to see the year here as well, then there's a lot you can do to customize the formatting of how the dates and times are displayed. Let's also label the X and Y axes so that we know what we're looking at. And to do that, we'll do p.x-axis, axis label. We'll call that timestamp local time. And then y-axis, axis label equals irradiance. That's watts per meter squared. All right, we got that. So we've got data from one of the irradiance columns here. Let's add the data from the other ones. When you're passing data from a data frame to a Bokeh figure, you can put it in what's called a column data source object. And that just, it's an object that works well for different functions that you might call within the Bokeh figure. It's not required that you use this, but it can be useful. So I'll just show how that works here. So we'll create a variable called CDS for column data source. And so our source is that IRAD data DataFrame. And now that we've created that, we can actually change how we're getting that X and Y data in the p.line call. So we can just say X equals timestamp. We can just give it that column name. So that's just that column name for Y, and then we just need to tell it that the source is CDS. And so if I run the cell again, everything should work the same. Yep, everything works. So to add the other series, we would need to add another p.line call for each series we want to add. When you're doing that with several columns, several series, the most efficient or simplest, cleanest way generally is to do it with a for loop. So I'll create that right here, and basically we're going to loop through that list of irradiance columns that I created earlier. So we'll call each of the column, call it call in irad calls, and then I'll need to tab that. And then now our Y is just going to be call. And so it's going to loop through those 4 irradiance columns in that list. And we'll run that. All right, so it's a little hard to see, but we actually do have 4 different series that are plotted now. Obviously, plotting them all in the same color is not very helpful because you can't distinguish between them. So let's assign them some different colors. And so I'll assign a colors variable here, and I'm going to give it the category 1010 palette, which is included in the Bokeh palettes collection. And this palette is just a list of 10 colors. And then to assign each of these to a different color, what I'm going to do is I'm going to enumerate this list in the for loop, and so that'll assign basically an index value, which I'm going to call I, each time that it goes through that loop. And then I will say color will be colors, which is that category 1010 palette, and the index, so that as on each loop iteration, it'll go to the next color in that color palette. So now we run it, and now we've got 4 different colors, so we can see things a little better. Of course, we still don't know which of these lines is corresponding to which channel, so it'll be helpful to add a legend. Just simple to do here. All we have to do is add a legend label, and for simplicity, I'll just give it the column name. So now we've got a legend that shows the column name that each of these different lines is coming from. Unfortunately, it's covering up some of our data. So I'll show you a little trick for getting the legend to display outside of the plot area, and that's using the add layout method. And we'll just have to reference the legend, and I'll put it on the right side. And there we go, much cleaner. And one last thing I want to do here is add some interactivity to the legend. So I'll say p.legend, I'll change its click policy to hide. Run that. And now that allows me to click on each item in the legend, and when I click on it, it'll show or hide that series. So if you want to just look at one, if the others are getting in the way, then you can just click on the others to hide them, or bring back just whichever ones you want to see. So there you have it. It's a nice handy time series plot for some solar data. So let's move on and try the same thing with our wind data. So we'll go through some of the same process for prepping the data to work with it. We'll look at our channel info. This site had a lot of anemometers, 12 anemometers connected to it. Let's go ahead and plot all of them. Let's look at all of our wind speeds, so channels 1 through 12. On this one, instead of using that sort of brute force copy paste method to pull together a list of channels that we're interested in, doing this in a more programmatic fashion. So this cell here will truncate that channel info data frame to include only the anemometers, and then using that, I'm using some list comprehension here to create this wind speed columns list. That's the column names just for those 12 channels, just for the average data of those 12 channels. So this is the resulting wind speed columns list. Those are the columns that we'll want to be plotting. And so to create our figure, we can basically do the same thing we did above. I'm going to go ahead and just, this is the one we used. Grab this. Oops. Copy. And paste. And we'll just need to make a few changes. So our column data source will now be I guess I didn't make a wind speed data frame, so I'll want to do that here. So wind speed data equals what's it? Wind site data timestamp plus wind speed columns should work. And so our source will be wind speed data. Colors, I'm just going to grab this line of code to use as my color palette here. So a couple of reasons I'm using a different color palette. One is because that category 10 palette only had 10 colors in it, and here we have 12 items, so we'll need a palette with at least 12 colors in it. Secondly is I prefer to use a continuous color palette if I'm working with data where there's an order to the different series that I'm plotting. So when I'm working with wind speed data, for example, that's wind speed at different heights, there is an inherent relationship between wind speed and height. And so when you have a continuous color palette assigned to those different series, it makes it easier to distinguish which series you're looking at relative to their heights. So yeah, what else do we need? We'll call this wind site wind speeds, and this we'll be going through our wind speed columns instead of our radiance columns. Everything else here should be fine. I'll change our line width to 1 just because since we have 12 series, so it doesn't get as cluttered. And then change this to wind speed meters per second. And let's hope I didn't miss anything. Let's run this. All right, here's our plot. And yeah, if I just zoom in a little bit, you can see why I like to use that sort of that continuous color palette, because it's really obvious. You know, the highest wind speeds, the highest heights are in the red color, you know, the lowest are in the blue color, and it just makes it easier to see you know, what that relationship is, and if anything, if any particular sensor is out of line. So yeah, I really like using these types of interactive plots for data QC because you can zoom in and out, you can scroll at different time periods. There's a ton more interactive features that you can add too, like if you wanted to be able to hover over and to see like the specific timestamp of any data point, for example. There's a lot you can do there. But you know, I also like to use Bokeh to make static plots for reporting, for example. So if you wanted to export this in a static format, I showed you could click this little save button. But if you want to do that programmatically, there is this command export PNG, and so you can just run that, give it a file name, and it'll take that P figure that we just created and save it to this file name that we assign it to. I have a little comment here that there are some additional dependencies required to use this function, so you'll just want to visit this link on Bokeh, which will give you the details on the additional dependencies that you may need to install for it to work. So you can see it output this, and I can so it's saved right in this folder. And I can just open that up as a PNG. So this is just just a static version of that plot that we created. And then, but if you also want to share the interactive version that we created, that can be saved to an HTML file. So you can run this line output file and then give it the name of the file that you want to save it to, and that's basically telling the code that the next time you run that show p command that was just showing the plot right in our notebook here, that you want it to also save it to this HTML file. And so now when you did the run sheet, when we did the show p, you can see it appears here in line again, but it also automatically comes up in another tab, and this is the HTML file. And if I go back to that directory, you can see there's this HTML file, and you can just share that with other people. You can send it to people, you can embed it in a website, and all the data and all sort of the interactive features are embedded right in this file. So I hope that some of you are inspired to go try this on your own with your own data. So if you want to learn what I showed here today, I really recommend that you go back, review the recording of the webinar, and follow along with it at your own pace. Pause where you need to, and actually write your own code. Just as I did here. In order to do that, what you'll need is access to a Python notebook environment. So if you have Python and Jupyter Lab installed locally on your machine, you can just run it, just do that right in Jupyter. If you don't have Python installed and that's not something that you want to pursue at this point, there are also a couple web-based notebook environments. For example, Google Colab and Kaggle. I'm not here to endorse any of those, but those are some tools out there that you can feel free to explore. As I mentioned in the beginning, you'll need to make sure that you have NRGpy, pandas, and Bokeh all installed in whatever environment you're using. So either on your local environment, on your local machine, or if you're using one of these web-based notebooks, they probably already have pandas and Bokeh available to you, but you will need to install NRGpy. And then in order to pull data from NRG Cloud, you will need to have an NRG Cloud account set up, which, as I mentioned, you can go to cloud.nrgsystems.com to sign up for a free account, and you'll also need access to sites on the cloud, access to data. So yeah, you can do that either through having sites on the cloud. If you don't already, if you just created a new account, if you have some SymphoniePRO RLD files, you can upload them to NRG Cloud, create a new site, and use it that way. And then alternatively, you can make all these same plots just by starting with locally saved SymphoniePRO export files. You don't need to necessarily download it from the cloud. So that's an option too. It's just you'll be using different syntax from what I showed today. And then, of course, if you want a better understanding of any of the code that I used in the demonstration today, or if you just want to develop more comprehensive knowledge of these tools so that you can use them more broadly, I really encourage you to spend some time with the documentation of these different packages. These, like the user guides for pandas and Bokeh, are excellent references. I look at them all the time. And if you're new to Python, you might want to check out the Python Beginner's Guide linked here. It'll point you to a range of resources to get you going, tutorials, online courses, books, however you learn best. There's something out there for you. And of course, these tools can be used for so much more than just time series plots. You can make any type of scatter plot, cumulative plots, histograms, distributions, heat maps, and much more, and add a lot more interactivity to them too. So this webinar is just meant to be a starting point. If you have any questions on anything that I covered today, please do not hesitate to reach out. If you want to learn more about NRGpy, learn more about NRG Cloud, just send me an email. My email address here is ndb@nrgsystems.com. And yeah, I hope you all learned something today, and thank you so much for tuning in.